Hello Professor, for this first part of my video I'm going to show you the simulation for the original Boolean expression from the exercise 10. This Boolean expression is read as A or B, and B or C or D, and A or C. So I'll be using 4 OR operations and 2 AND operations. I have my inputs A, B, C, and D. And I have a few expressions which are called or 1, or 2, or 3, and end. Now let's start our simulation. Let's try with all with and zeros and see what happens. Okay, all zeros, the LED's off, it's okay. Now let's try all in 1. And okay, the LED is turned out, so fine so far. Now let's try with something more complicated. So 7 represented in binary, it could be read as 0, 1, 1, 1. So let's just turn on the 0, and my output in my truth table, well, it's 1, so it means it's okay. So let's see how it's distributed in order to my circuit to work. Okay, so here I have my OR and my AND gate. Okay, and the output of everything is connected to my LED and also to the ground. In the deep switch, well, I assigned it as in the alphabet, A being the first, B being the second, C being the third, and D being the fourth. Okay, so let's test it with net, which is going to be equal to 0, 0, and, well, it's going to be, sorry, equal to 1, 0, 0, 1. Okay, it's turned out, and in my truth table, its height is 1, so it means it's correct. Okay, well, I already tried with 4 different numbers with all zeros, all ones. I think it was 7 in binary and 9. I think it's enough to demonstrate that my circuit and my truth table works the same way. And next, let's move on to the second part of my video. In this second part of the video, I'll show you the simplification from my Boolean expression. This simplification was really easy, as you can see on the right. I only had to research for one theorem, and the rest of my operations were done manually. The theorem that I used was that A or B and A or C is the same as A or B and C. Then I did the AND operation with A and B or C or D, and then the OR operation with AB or AC or AD or BC. And that's all for my simplification. Now, as you can see in my circuit, the main difference is that I'm using the AND gate first. I use the same color code for the outputs in the deep switch, and they are connected to perform their respective AND and OR operations. Now I'm going to proceed to my simulation. I'll start with all in zeros, then in 1, and I'm going to make some movements in order so you can check it in the truth table. Okay, now I'm going to compare it with my other circuit, which I have just here. So let's put them this way. It's turned again, so it's turned down here. Then this movement, then this orange, and it's the same.